Welcome back to the Maths Guy. This is lesson 4 in our 10 lesson series for our grade 4 maths, and we're starting our work on fractions, so let's begin. Today we are going to be looking at equivalent fractions together, and we've got these 4 questions. But the first thing we need to think about is, what is an equivalent fraction? So I want to show you this chocolate bar. Now, I could chop this chocolate bar into halves, and I could offer you this 1/2 here, and you would get 1/2. Or I could give you the same value, but I could give you these 2/4. So here we have 2/4, but it has the same value. So just because it looks different, this 2/4 is the same value as 1/2, and therefore that makes it an equivalent fraction. So an equivalent fraction is basically just a fraction that looks different, which has been split differently, but has the same value. Okay. So let's have a look at question 1 together then, and let's see what we need to do to answer this. So we're going to look at question 1. We're going to look at this 1/2. Okay, and let's have a look at trying to find some fractions for it, some equivalent fractions for it. And we have these 3 steps. We have step 1, which is to multiply or divide. Then we have step 2, which is to multiply the denominator. And then we have step 3, multiply the numerator by the same amount. So what is a denominator and a numerator? Well, the denominator is this digit under the bottom. So this would be the denominator. And the numerator is this one at the top. This is the numerator. Okay? Now, the denominator is showing you how many your item has been split into. So if we go back to our chocolate bar has been split into 2, so our denominator is 2. And then the numerator, the top number, refers to how many you're getting. So if we have 1/2 here, we have 1, and then over here we have another 1/2. Okay? So let's begin, and let's follow our steps. So step 1 says multiply and divide. Well, what does that mean? It means that multiplying and dividing is what we're going to do to find an equivalent fraction. But what I can see here is that we can't divide because 1 cannot be divided. So we're going to have to multiply. So I've done step 1, I've decided I'm going to multiply. And then it says step 2, multiply the denominator. So I'm going to pick my denominator here, and I'm going to multiply it by something. For example, multiply it by 2. 2 times 2 equals 4. Then it says step 3, multiply the numerator by the same amount. So I need to, whatever I've done to the bottom, I'm going to do to the top. Whatever I've done to the denominator, I'm going to do to the numerator. I times the denominator by 2, therefore I need to times the numerator by 2 to keep it the same value. And 1 times 2 is 2. Okay, and what do we see here? Well, we see that we have a 1/2 being the same equivalent value as 2/4. And we saw that earlier, didn't we? 1/2 is the same as 2/4. So we know that's right. Let's do another one. Let's times it by 10. So again, I'm going to multiply, but this time I'm going to multiply by 10. 2 times 10 is 20. And then whatever I've done to the denominator, I need to do to the numerator. So I'm going to times the numerator by 10. 1 times 10 is 10. Therefore, 10/20ths is an equivalent fraction to 1/2. And I could do this forever. There's an unlimited amount of times that I could find an equivalent fraction, depending on the numbers I multiply it by. Let's multiply it by 5. 2 times 5 is 10. Multiply 1 by 5 is 5. 5/10ths is an equivalent fraction. Okay, let's pick a different question. Let's pick a harder one. Let's have a look at 4/16ths, okay? So, same steps. I'm going to choose whether I multiply or divide. Then I'm going to multiply the denominator, and then I'm going to multiply the numerator by the same amount, or divide. Okay? But in this case, my step 2 and step 3 might be divide instead of multiply. So let's have a look. Now I have 4/16ths. Now I can see straight away that I can divide if I wanted to, because I can divide the number 4. I know that, for example, 4 could be divided by 2. And I'm going to start again with my denominator, and I'm going to divide by 2. 16 divided by 2 is 8. And remember, whatever I do to the denominator, I have to now do to the numerator. So 4 divided by 2 is 2. So 2/8 are the same as 4/16. Same value. If we were going to get our chocolate bar and cut it up, having 4/16 of it would be the same as having 2/8 of it. Okay, let's do another one, because I can see another division 1 in here as well. I could divide by 4. So let's do 16 divided by 4 is 4, and 1 divided by 4 is 1. 1/4. So 4/16 is actually an equivalent fraction to 1/4. And we call this equivalent fraction here the simplified version, because this is its lowest form. These are the smallest numbers, the smallest digits that we can use in this fraction to show its equivalent value, 1/4. So this is how we really want to see all of our fractions, in the equivalent form. Let's do one more where we multiply. Let's do a crazy one. Let's multiply by 1,000,000. Crazy. Okay, so 16 times 1,000,000 is 16 million. And 4 times 1,000,000 is 4 million. So 4,016,000,000ths is an equivalent fraction. Looks pretty crazy though, right? Well, that's because it's got huge digits. But don't forget, it's the same value. You might look at that and think, well, I'm going to get loads of that chocolate bar. But actually, you're going to get exactly the same amount, because the chocolate bar has been now split into 16 million pieces. You're going to get 4 million of them, but each one is going to be tiny. Okay, let's look at another one. Let's have a look at one like this, because this is what you might see sometimes. You might see an equivalent fraction where they already give you the denominator. So let's see how we solve this one then. Now we're going to have slightly different steps this time. First, we're going to find the connection between the denominators. Then we're going to find the multiple or the divisor, and then we're going to multiply the numerator by that same amount. So first of all, we're looking for the connection. Well, I can see a connection straight away. I can see that 27 is in the 9 times table. How do I get from 9 to 27? 9, 18, 27. I'm going to times it by 3. And remember what we learned from the last question, whatever we do to the denominator, we need to do to the numerator. So therefore, if I've times the denominator by 3, I need to times the numerator by 3. 3 times 3 is 9. So the answer to this question is 3/9 is the same as saying 9/27. Give ourselves a tick. Nice and simple, right? Okay, let's have a look at one last one. Let's have a look at this one here. And this is slightly different. This time we've been given the other numerator, and it's a 9. So let's see what our steps for this would be. Step 1, we need to find the connection between the numerators this time. Then we find the multiple or the divisor, and then we multiply or divide the numerator by the same amount. So can we see a connection here already? Well, I think I can. I think from getting from 3 to 9 is in the 3 times table, and I can go 3, 6, 9. So again, it's multiplying by 3. So remember, whatever I've just done to the numerator, I now need to do to the denominator. Step 3 times 5 by 3 is 15. 9/15 are the same as 3/5. So a couple of things to point out at this point. Firstly, one really important rule: to make sure that we're keeping these fractions equivalent, we need to do the same process to the top as we do to the bottom. Same process to the denominator as we do to the numerator. So whatever we do to the denominator, whether we times it by 1,000,000, divide it by 5, times by 2, we would need to do the exact same thing to the numerator. It's really important to keep it equivalent. We need to keep those multiplications or divisions the same. That's the first thing. The second thing is, why do we even need to find out what an equivalent fraction is and how to find one? Well, we're going to get into that much more throughout this fraction series, because when we get into things like adding fractions or comparing fractions, sometimes we need to get the same denominators or numerators to help us. So finding an equivalent fraction will be what we do to help us do that. So keep that in mind for our next lesson, guys, which is going to be how to compare our fractions. Cool. Hope this has been useful to you guys. If it has, think about giving us a like and a subscribe. Check out the website, www.themathsguy.com, and we'll see you in another video Peace out. What's up everyone, and welcome back to the Maths Guy. Today we're going to be looking at a new lesson on our fraction series. We're going to be looking at comparing fractions that have the same denominator, and we're going to be looking at these three questions here. So let's begin. So the first thing we need to think about is, what is a fraction? Well, we can have two types of fractions. We can have fractions of amounts. So for example here I have 16 basketballs, but what I could do is I could cut them in half. Therefore half is 8 basketballs. Or I could cut them into a quarter and have 4. So we have fractions of amounts, but we also have fractions of just one. So for example we have one car here, but if I was to think about this wheel here, this wheel is a fraction of the car. It's a part of the whole. So the car is the whole and this wheel is a fraction of it. And again, looking at our chocolate model, we can see this chocolate here, we could cut it into halves and make 2 halves, or I could cut it into quarters and have 4 quarters. Then when we look at a fraction itself, it will look like this. We have what's called the numerator on the top, and on the bottom we have the denominator. Now the denominator is how many your one or your group is split into. So for example here we had our chocolate bar that was split into 1, 2, 3, 4. Therefore each quarter the denominator is a 4 to show it's been split into 4. And the numerator, the number on the top, quantifies how many you're getting or how many you're considering in the question. So 1 quarter would look like that with 1 on the top. But if I had 2 of them, I would change that to 2 quarters. And again for 3, I would have 3 quarters. Or for the whole thing, I would have 4 quarters or 1 whole. And then when we're looking to compare them, we will have these 3 symbols that are going to help us do that. We have this top one, which stands for greater than. We have the middle one, which is equal to, and then we have the bottom one, which is less than. So let's see how they work. Well, if I'm saying something is greater than, I would have the bigger number or the bigger value at the start. So 5, for example, is greater than 2. Or I could have 1/2 is greater than 1 quarter. We could have also equals. Equals would look like this. I could have 1 equals 4 quarters. A little bit like what we looked at here. 4 quarters is the same as 1 whole. Or simply I could have 2 equals half of 4, for example. And on the bottom one this says less than. So it means that whatever's on this side needs to be less than what's on the other side. So for example I could say that 1 is less than 4. Or 4 is less than 6, etc, etc. So these 3 symbols are what we're going to use to help us order and compare these fractions. One way that people like to think about this is a crocodile's mouth. Imagine this is a crocodile. The crocodile would rather eat the bigger value, the most amount of food. So if we had a 5 here and a 2 on this side, the crocodile would face and open his mouth to the biggest number or the bigger value. Okay, so let's have a look at our first question. We're going to have a look at this one. 3/9 versus 4/9. Which one's greater? Let's have a look. So the first thing I notice is both of my denominators are the same. They're split into 9. So whatever we had, chocolate bar, quantity of people, car, we've split it evenly into 9. Now that's a really important word, evenly. We have split these in evenly, because otherwise fractions don't work. If we're uneven, fractions won't work. So everything that we're thinking about with fractions are an even share. Okay, so we split them into ninths, and my first one says I have 3/9, and my second one says I have 4/9. So which one's greater? Which would you rather have? Well, what I think helps a lot is turning this into a bar model to help us see it. So I can have a look at my fractions like this. And the first one says 3/9. So I've chopped my chocolate bar, imagining this green line is my chocolate bar. I've chopped it into 9 even sections. So let's do that for a second. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then what it's saying is, this first one, I have 3/9. So I have this one, I have this one, and I have this one. So I'm having 3/9 of the chocolate bar. On my second one, again, the same value chocolate, the same amount. You can see my green lines start on the same point and end on the same point. That's really important to show the value of the chocolate in the first place is the same. But what this one's saying is that now I have 4. So let's chop it up. 1, 2, 3, 4, 5, 6, 7, 8, and 9. But this time I'm getting 4. So 1, 2, 3, 4. Now, which one would you rather have? Which is the greater value? Would you rather have 3/9 of the chocolate bar and get this amount? Or would you rather have 4/9 of the chocolate bar and get this amount? Well, I can see if I draw my line, the 4/9 is more than the 3/9. So it looks like if the denominator is the same, then the number on the top, the numerator, the greater number, the greater digit, will be the greater value of chocolate or whatever we're splitting up. Let's see if that works for another question. Let's have a look at the second one. So now I've got 3/7 or 6/7. Let's see which one is greater. So again, the first thing I'm going to do is I'm going to think about creating my model. And I'm going to imagine I've got that chocolate bar again, but this time I'm only splitting it into 7. Let's do that. 1, 2, 3, 4, 5, 6, and 7 pieces. This top one, 3/7, I have 1, 2, 3, but my bottom one, again, chopped into 7 pieces according to my denominator. But this time I'm getting 6 of them. 1, 2, 3, 4, 5, and 6. So it's pretty obvious, isn't it, which one we would rather have? We've got much more in this one than we have in this one. So again, the greater numerator wins, or is greater. Let's have a look at our final question. Let's have a look at 2/5 versus 4/5 and see if the same rule applies. Now this time I'm going to try and do it without drawing my bar models. And I'm just going to try and think through the question. So what it's saying is that my chocolate bar or whatever would have been chopped into 5 equal pieces. And in this one I would get 2 of those equal pieces, but in 4/5 I would get 4 of those even pieces. So what makes sense? What's logical? Well, it's logical that if I'm getting 4/5 of something, that it's greater than having 2/5. So I think, without having to draw my chocolate bars, I think we know that 4/5 is greater than 2/5. So now let's go back and actually answer these questions using those symbols we learned earlier. So the first one said 3/9 versus 4/9. Well, we agreed that 4/9 was the greater value because we had 4 parts of 9 compared to only 3 parts of 9. So we would write it like this. We could say 4/9 is greater than 3/9. But that's not the only way I could write it, is it? Because what I could do is flip that around and I could say that 3/9 is less than 4/9. And that would still be right. Let's look at our second question. Our second question said 3/7 versus 6/7, and we agreed that 6/7 would be greater. So therefore I could write 6/7 is greater than 3/7, and I'd get that question right. Or I could write 3/7 is less than 6/7, and that would still be right. Okay, let's do our last one. We had 2/5 and 4/5, and we agreed that 4/5 was greater than 2/5. Or again, I could flip that round and say that 2/5 are less than 4/5, and that would be right. Good job. Okay, I'm going to put 3 questions on the board for you. Here they are. What we're going to do is press play, and then when you think you got an answer, I'm looking for which one is greater, the bigger value. Put the answers in the comment section. Okay, are you ready to press pause? Press pause now and put the answer in the comment section. Okay guys, I hope this video was useful. This was looking at comparing fractions with the same denominator. If this is useful, I really would love it if you could subscribe to the channel. It really helps us out. and also it'll help you out because we're going to be carrying this series on. And our next lesson that we're going to be looking at is comparing fractions with different denominators. And that's when things can get a bit tricky. So make sure you check that video out, guys. Okay, peace out for now, guys. Bye-bye. Welcome back to the Maths Guy, everyone. Today's lesson is comparing fractions with different denominators. Let's start. Okay, so today we're going to be working on these three questions here. 3/4 versus 4/12, 3/4 versus 4/5, and 2/5 versus 1/3. So let's begin, and let's begin here with 3/4 versus 4/12. So if we're going to look at 3/4 versus 4/12, what we're asking is which fraction has the greater value. So we could look at it like this, and we could say that, okay, my 3/4, this is quite clearly 4 is our denominator, so we need to have 4 sections, 1, 2, 3, 4, and 3 being our numerator means we get 3 of these sections, so 1, 2, 3. And then we can look at 4/12 and realize we have to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections, and this way we're getting 4 of them. So on the surface it might look like 4/12 is greater because it looks like you're getting more. But this would not be the way to do it. This is wrong, because when we're looking at comparing two fractions, unless it's a mixed number fraction, which we'll get to later, both of these fractions are fractions of 1, the same value. So when we create our bars like this, we have to have it the same length. Can't have it like this with different lengths. That would be wrong. So our bars have to be the same length. So 3/4 would be 1, 2, 3 as before, but our 4/12 now would only be these small little segments. 1, 2, 3, 4. So now when we look at it, we can quite clearly see 3/4 is more. But this is not a very convenient way of doing it. We need an alternative method because we can't be drawing bars all day and we might not get them very accurate without proper measurements. So we need an alternative. And that alternative is gonna be this, equivalent fractions. And if you've not checked out my video on equivalent fractions, this is your time to press pause and go and watch that first, because that's really important and that's what's gonna help you understand this. Okay, so what is an equivalent fraction very quickly? It's a fraction that has the same value but looks different. Might have a different denominator and a different numerator value, but the value of the whole fractions are the same. So what we need to do to these, we can try and find an equivalent fraction of one of these to try and make it so that we have the same denominator. Because if we have the same denominator, it's going to be super easy to compare. A bit like in the previous video when we were comparing fractions with the same denominator. So now what can we see straight away? Well, I can see that actually this 4 has a relationship with this 12. And I don't mean it's his mum, I mean it's got a mathematical relationship. What I can see is that 12 is in the 4 times table, because if I times 4 by 3, I get to 12. So I'm going to turn this into an equivalent fraction. So I'm going to make the denominator a 12. And I realized that from getting from 4 to 12, I had to times by 3. So therefore, as we know about equivalent fractions, whatever I do to the denominator, I also need to do to the numerator. So the 3 is also times by 3, which would become a 9. So now my two fractions that I'm comparing are 4/12 and 9/12. And that's suddenly really easy, isn't it? Because I can clearly see that 9/12 of something would have a greater value than 4/12. And I can see that just very quickly in my bar model again. So my 9/12 would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9 versus my 1, 2, 3, 4/12. So my 9/12 is greater. So let's go back to the question. And we now know that 3/4 is the same as 9/12. But the question said which one is greater, 4/12 or 3/4. So I'm going to write it like this. 3/4 is greater than 4/12. I'm not going to put my 9/12 because that's the equivalent fraction we made up to help us. I'm using the two fractions that we started with. And now I've just used a funny little symbol, this one here. If you saw the previous video, you will realize that that means greater than, but we have three symbols that are very important when we're comparing. We have the greater than symbol, the equal to, or the less than. and these work a little bit like this. I'll do this very quickly. 6 would be greater than 3, 2 would be equal to 1 plus 1, and 1 is less than 3. So that's just a very quick look at that. So let's keep using these symbols as we answer the next 2 questions, and let's start question 2. We're going to have a look at this question here, 3/4 or 4/5. Again, our denominators are different, so we're going to need to do some magic. So what can I see here? Is there a relationship? Well, not an obvious one, because 5 is not in the 4 times table, or 4 is not in the 5 times table, so there's not an obvious one. So I now need to find a number that would be in both of their times tables. So I'm going to go up in a couple of their times tables and just show you a method to do this. So I could go 4, 8, 12, 16, 20, 24. I'm going to stop there for a moment. And then in my 5 times table, I could do 5, 10, 15, 20. Oh, I see something. I have a 20 over here, and I have a 20 on this side. So now I'm going to make equivalent fractions for both of these, but with the denominator 20. Okay, well, how did I get from 5 to 20? I have to multiply by 4, so therefore I have to do the same thing to my numerator. So therefore 4 times 4 is 16. So 4/5 is equivalent to 16/20. Okay, well, how did I get from 4 to 20 on this side? I had to multiply by 5, therefore I have to multiply my numerator by 5, and 3 times 5 is 15. So I have 15/20 or 16/20. So now I can see that the 16/20 has a greater value. So again, to answer my question, I need to write 4/5 is greater than 3/4 or 3/4. Okay, that was slightly harder. We had to find a common factor. Let's look at another way of doing that on question 3. So question 3 is this one, 2/5 versus 1/3. And what I can see straight away is I don't have that obvious relationship between the two numbers. 3 is not in the 5 times table and 5 is not in the 3 times table. So I need to find that common factor again. What I could do is do my multiplication table all the way down until I find a common one, or I can do a little trick. I'm going to show you a little sneaky trick here. So watch this. If I get my 5 and my 3 and I multiply them together, it gives me 15. Now, because I've multiplied them together, that 15 has to be a multiple of both of them. Therefore, 15 is a common multiple, so I can just use that. So again, let's start from here then. So I know that 15s are going to be my denominators. Well, how did I get from 3 to 15? I know I multiplied it by 5. So whatever I do to the bottom, I must now do to the top. The numerator times it by 5. 1 times 5 is 5. So 1/3 is equivalent to 5/15. Okay, well, how did I get from 5 to 15? I multiplied by 3. Therefore, what I did to the denominator, I now need to do to the numerator, times it by 3. 2 times 3 is 6. Okay, so now I'm at this point, I can clearly see again that I have 6/15 or 5/15. Therefore, my 6/15 has the greater value. 2/5 has a greater value than 1/3. So I would write it like this. 2/5 is greater than 1/3. And I'd give myself a nice big shiny gold tick. So there's a sneaky little trick, isn't there? We can look at our two fractions, and rather than trying to work out which is the lowest common multiple, I can just multiply them together and it will give me a multiple that I can use. And then whatever I do to that denominator, I have to then do to the numerator. That's a really useful trick. Okay, I'm going to give you these 3 questions. What I want you to do is try and work out which one has the greater value, and I want you to try and put the answers in the comment section. So press pause on the video in a moment, have a go at working them out, and then put the comments in the answer section, and I'm going to try and mark every one. Okay guys, I hope this video has been useful to you. This is a really important stage in fractions to understand how we can use equivalent fractions to order and compare, and it's going to help us in the future lesson, which is going to be adding and subtracting these fractions. So if you've enjoyed this video or it's been helpful, please think about giving it a like and subscribe. Check out our website, www.themathsguide.com, and we're going to see you in a future video, guys. Peace out. What is up everyone? Welcome back to the Maths Guy. Today we're going to be looking at how to convert from improper to mixed number fractions. So let's begin. Okay, we're going to be working on these three questions today, and we're going to find out exactly how to convert them from these horrible looking improper fractions to a mixed number fraction. So an improper fraction looks like this, where we have a larger numerator than we have denominator, and a mixed number has both a whole number and a fraction, a bit like this. And ideally we want our fractions to be a mixed number rather than improper. So let's find out how to do that. So if I look at this first fraction, 17 fourths, what I'm actually saying is that I have 17 quarters. So we could look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I could do this bar model and draw this out every time, and then I could work out that I actually have 1 whole, 2, 3, 4 whole, so that would be my whole number, 4, and I still have 1 left over here. So I have 1, and what value are we working in now? We're working in quarters, so I'd have 1 quarter left over. So 17 fourths is the same as saying 4 and 1 quarter. Write that a bit better. But we don't want to do that every time. We don't want to have to draw out these bar models, so we need a better way. And that better way is going to be division, okay? So what we actually have just done here is we divided our 17, our whole 17, by 4. We worked out how many 4s are in 17. We had 1 group, 2, 3, 4, with 1 left over. So we had 4, remainder 1. That's where we got our 4 whole, remainder 1. So let's try and do division this time then. So we've got 17 fourths, so what we know now is if I put my 17 inside my bus stop and 4 on the outside, how many 4s are there in 1? There are 0, carry the 1 across. How many 4s are there in 17? 4, 8, 12, 16, we get 4, remainder 1. So I would write it as in 4 with 1 left over. But I'm not finished, because what are we working in? We're working in quarters. So my answer is actually 4 and 1 fourth, 4 and 1 quarter. And I'd give myself a big tick for that question. Okay, let's have a look at our second question. We have 18 fourths. Okay, and then when working this out now, we're just going to use our division method. And I can say 18 divided by 4. Okay, how many 4s are there in 1? We have 0, roll the 1 across. How many 4s are there in 18? I have 4 again. Okay, how many left over? Well, 4 got me to 16, so I have remainder 2. So we write it 4 with 2 quarters. Nice. And I get myself another green tick. Let's have a look at our final question. 15 fifths. And this one's a little bit different. So let's have a look. So we have 15 fifths like this. And again, I can just use my bus stop method to work out the division. 15 inside, 5 on the outside. How many 5s are there in 1? 0. Roll the 1 across. How many 5s are there in 15? 3. Now we have no remainders this time. So what does this fraction look like? Well, I could simply write it like this. 3. We have 3 whole. If I have 5 15ths, I have 3 whole. And I can show that in my bar models again. I'm just going to do a very quick bar model. 1, 2, 3, so I've got 15 fifths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have a whole one, another whole one, and another whole one. 1 whole, 2 whole, 3 whole. Giving my answer 3 whole. Okay, I hope that was useful. Here are 3 questions for you to have a practice at. See if you can find out the mixed number for this fraction, please. When you get an answer, put the answer in the comment section. I'm going to try and mark every single one. So 3 questions here, press pause, good luck. Okay guys, hopefully that was useful. If it was, think about subscribing to the channel, give us a big like, that'd be really helpful. And check out our next video where we're going to be looking at adding and subtracting fractions. So I'll see you in the next video. Peace out. Welcome back to the Maths Guy, everybody, and today we've got a new lesson looking at how to convert from a mixed number to an improper fraction. Let's begin. Okay, so today we're looking at these 4 questions here, and these are mixed numbers. If you were in our last lesson, you would see that we were converting from an improper fraction to a mixed number, and now we're doing the opposite way round. Okay, so let's start on our question 1. Question 1 says 3 3/4, and now this is a mixed number because we have a whole number and we have a fraction. So how do we convert this back to an improper fraction? Well, let's dive in and look at the understanding of this before we look at the method. So 3 3/4 can be represented in this bar model by having 3 whole, 2 and 3, and then 3/4 of another one. So then an improper fraction is basically asking how many quarters do you have, but without the mixed number. So we can see here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So therefore this would equal 15 fourths, and this would be the improper fraction. Now again, this is really useful to help us understand what's going on, but it's not a very practical method for us to work it out every time, so we need another way. Now our fraction that we're working with here is quarters. So we know we're going to have something quarters as our improper fraction, and the way that we can find out how many quarters we're going to have is we can simply times our 4 by our 3. And the reason that is because look, we have 3 whole, 2 and 3. Each of these wholes is split into 4, so therefore if I times 3 times 4, it's going to give me how many quarters I have in my whole number. So the answer to 3 times 4 is 12. But I'm not finished yet because of this last 3 here. Now this is just 3 on its own, 1, 2, 3, so therefore I need to plus 3. So my fraction is 12 plus 3 fourths, therefore it's going to be 15 fourths. Okay, so the answer to question 1 is 15 fourths. Okay, let's have a look at question 2. Let's have a look at 5 2/3. So 5 2/3. Well, let's not bother building those bar models again. Let's go simply into the method. So the first question I want to ask myself is, what is my fraction? And in this case, it's thirds. So I know that my answer is going to be in thirds for the improper fraction. How many thirds do we have? Well, let's find out. How many thirds do I have in my whole? And I know now that I can just times 3 by 5, and 3 times 5 equals 15. So I have 15, but remember I'm not done because I've got this pesky little 2 here, and that was just going to be added on. So 15 plus 2, therefore the answer is 17 thirds. So the answer to 5 2/3 is 17 thirds as an improper fraction. Now before we move on, let's just make sure that's right by flicking it back to a mixed number in the way that we learnt in the previous lesson. So if you haven't learnt that, go back and check that out as well. So we're going to turn it back into a mixed number by simply dividing 17 by 3. Because if you think about it, division is the inverse of multiplication, so we're going to obviously divide at this point if we're trying to find the opposite. So how many 3's are there in 17? Well, there's 5, remainder 2, so therefore my mixed number is going to be 5 2/3. Is that correct? Yes, it is. So we know this is right. So 5 2/3 is 17 thirds. Awesome. Okay, let's look at question 3, 10 1/5. So 10 1/5, let's do this really quickly now. So what we can do, we know we're going to be working in fifths, and we know that we can multiply our 5 times 10 is going to be 50, plus the 1 is 51. So I've got 51 fifths. Huge improper fraction there. So my answer to 10 1/5 is 51 fifths. I'm going to give myself a tick for that question. Okay, final question, and we're going to look at question 4, 8 1/2. And the question is asking me how many halves do I have, so I know that therefore I'm going to have halves as my denominator, and let's just simply times 8 times 2 is 16, plus my 1 is 17. So I have 17 2's. Super quick once you learn the method. But remember, the understanding of this is just as important as being able to get the correct answer. So if you didn't fully understand how I did this and how we got these improper fractions, go back to our understanding screen and see it with the bar models again. Okay, we're going to move on to some questions of your own. I've got 4 questions here for you. press pause on the video, take some time to answer them and put your answers into the comment section, and I'm going to do my best to mark every single one. So press pause now and I'll see you in a minute. Okay, I hope this video has been really helpful for you. If it has, please think about giving me a subscribe and a thumbs up. It really helps me out on this channel. And also check out my website, www.themathsguy.com, where there's going to be lots of more videos and lots of resources on there for you. But for now, peace out. Welcome back to The Maths Guy, everybody. I am Matt the Maths Guy, and today we're looking at a new video, adding fractions with the same denominator. Let's go. Okay, so adding fractions with the same denominator. This is very different to adding fractions with different denominators, which is going to be our next lesson. But today we're looking at the same denominator. So you can see in our 4 questions here, all of our denominators are the same. So in 2/5 and 1/5, we have 5 as our denominator. In 3/6, add 1/6, we have 6 as our denominator. And in 4/9 and 2/9, we have 9. 3/8 and 5/8, we have 8. Okay, so let's first jump into our understanding stage to understand how this works before we have a go at understanding the method. So let's have a look at this first one together. Super simple question, 1/2 and 1/2. Well, we know that if we add 1/2 to 1/2, we should get a whole. So let's try and get to one whole in this question. So first thing we might think of doing is we might try to add our numerator and our denominator. And this is the most common mistake I see. And let's see what happens if we do that. If I add my numerator, I'll get 1 add 1 equals 2. And if I add my denominators 2 and 2, I will equal 4. Well, if I now show that in my model again, 2/4 or 2/4, well, is that now not just the same as what I had? 2/4 would be 1 and 2/4. That looks very much like what I had before, because 2/4 simplified is 1/2. So what I'm saying here is 1/2 add 1/2 equals 1/2. Well, that sounds very wrong, doesn't it? How can 1/2 and 1/2 equal a half? So we can't do this. We can't add our numerator and our denominator. So we need another way. So let's look at it in a different way. And let's look at it with the bar models again. So I have 2/5 and I'm adding 1/5. So in my first bar model, I can see I have 1 2/5. And in my second one, I have 1/5. So how many do I have altogether? Well, I think I can answer my numerator. I have 1, 2, 3. So I have 3. But I have 3 what? 3 what? 3 dogs? 3/10? What? Well, let's think about it in this way. If I have 2 elephants, add 1 elephant, I'm going to have 3 elephants. Let me draw an elephant for you. Look at that. Beautiful. I should be an artist. So my answer would be 3 elephants. So would it not make sense if I'm adding 2/5, add 1/5, then my answer would be 3/5, because that's what my fraction represents, fifths. I have 1/5, 2/5, and I'm adding a 1/3 fifth, so I have 3/5. Because remember, the denominator, the number at the bottom, is basically the name of the fraction. What fraction are we working in? Are we working in thirds, in fifths, in eighths? And that will not change if we add fractions together. Because if I add 2/5 to 1/5, I'm getting 3/5. So I keep the denominator the same when I add. I only add the numerator. So back to my questions. 2/5 add 1/5 equals 3/5. And I'll give myself a nice tick. Okay, question 2, 3/6 add 1/6. Well, let's do it in our super quick method now. I know that I'm working with a 1/6. I have a 1/6 here and a 1/6 here, so I know that my answer is going to also be in 1/6. And how many 6ths do I have? Well, I have 3/6 add 1/6, which equals 4/6. Let's check it with my bar model. Here we go. I'm just going to draw a very rough one for us. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Excuse my inaccuracy. But on my first one, I have 1, 2, 3. And in my second fraction, I only have 1/6. how many do I have altogether? I have 1, 2, 3, 4 sixths. So my answer to question 2, 3/6 add 1/6 equals 4 sixths. But hold on, because I think we have a simpler form of this fraction, because I can see here that 4 and 6 has a common factor of 2. So if I divide 4 by 2, I'll equal 2, and then 6 divided by 2 is 3. So my actual simplified answer is 2/3. 3/6 add 1/6 equals 2/3. Give myself another tick. If you don't know how to simplify a fraction, I have a designated video for that on this channel, so check it out before you carry on too far with this. Okay, question 3. 4/9 add 2/9. Here we go, and I'm just going to do this in my super quick method now. So I'm adding 9ths, so I have 9ths, therefore my answer must be in 9ths too, and I can simply add my two numerators together. 4 add 2 equals 6. 6/9. And can any of you see a common factor between my 6 and 9? Well done, I have 3. I can divide 6 by 3, leaving me 2, and I can divide 9 by 3, leaving me 3. So 4/9 plus 2/9 equals 2/3. I can put that into my answer box and give myself another tick. Now last question here is a little bit different. I have 3/8 plus 5/8. Let's have a look at it. 3/8 plus 5/8. So same thing again. I'm working in eighths. Therefore my denominator will still be an 8. And now I can just add my two numerators. 3 add 5 equals 8. 8/8. Let's have a look what that looks like in our bar model. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have the whole thing. So 8/8 actually equals 1, or 1 whole. So the answer to 3/8 plus 5/8 actually equals 1. Give myself a funky coloured tick. Okay, so a few things to think about. When we add fractions with the same denominator, our denominator will stay the same because that's the fraction we're adding up in. We are adding fourths or fifths or thirds, and we simply just add the numerator. And then we simplify if possible. Okay, here are 4 questions for you to work on. Have a go at answering them and then put the 4 answers into the comment section and I will try and mark every single one. So press pause on the video now and I'll see you in a minute. Okay guys, well done today. I hope this video has been helpful. If it has, please consider thinking about subscribing to the channel because we're going to be making daily videos for you. And check out the website www.themathsguy.com for even more videos and resources. But for now, see you in another video and peace out. Welcome back to the Maths Guy. Now we are going to look at working out how to add fractions with different denominators. Let's check it out. Okay guys, so we're working with these 3 questions today, and the first thing I can notice is that we have now different denominators in our question. So a denominator, as we know now, is the number underneath the fraction. Our numerator is the number on the top. So as you can see in these questions, I have different denominators that I'm trying to add. I'm trying to add 2/3 to 4/9, 3/10 to 5/6, 3/8 to 2/4. So let's jump into our understanding stage to find out the steps to solving this. So step 1 says find a common denominator. So we're going to be looking at equivalent fractions. So if you haven't checked out my previous video on equivalent fractions, or you don't have a good understanding of equivalent fractions, press pause on this video, go and check that out, and then come back to this, because equivalent fractions is something we're going to really need to understand before we can move on with this. And then I need to rename the fraction into my new equivalent, add the numerators, and simplify if needed. So let's see what that looks like. Question 1 says 2/3 plus 4/9. So some of you straight away can look at my denominators and we can see a relationship here. And the relationship is that 9 is in the 3 times table. So therefore I can use that knowledge to help me find an equivalent fraction. What I'm going to do is I'm going to look at this fraction here and I'm going to try and turn it into a fraction with 9 as a denominator. So how can I turn my 3 into a 9? Well, therefore I'm going to have to times by 3. Turns my denominator into a 9. Good, that's a good step. But now if I've done that to my denominator, what do I now need to do to my numerator? That's right, well done, we need to times that by 3 also. As I say, if you don't fully understand why, go back to the equivalent fractions video to see that part. So 2 times 3 is 6. So my equivalent fraction is 6/9. So now I can get rid of this fraction temporarily and simply add 6/9 to 4/9. So let's do that. I'm going to tidy it up and bring it down here. Now I can look back to the previous lesson of adding fractions with the same denominator, and I realize that I'm working in ninths, so therefore my answer will still be in ninths. And all I need to do is add my numerators. 6 plus 4 is 10. Let's check my steps. I found the common denominator, I renamed the fraction, I added the numerators, and it says now simplify if needed. So can I simplify this fraction? Well, this fraction is actually an improper fraction because we have a bigger numerator than we do denominator. So I can turn this into a mixed number by dividing my 10 by 9, and that's going to give me 1 and 1/9. Therefore, that is in its simplest form. Great, let's keep our understanding going here and look at this in a bar model. So originally my question said 2/3 plus 4/9. So I could have done this. I could have said 1 2/3, add 1 2 3 4/9. But then you can see that this is really difficult to add up because I'm working with different volumes and different quantities of my fraction. This is in thirds and this is in ninths. It's very hard to add a third to a ninth. So what we did is we found an equivalent fraction, the 6/9. And now it's much easier to see that when we're adding these together, we are simply adding the same quantity, the ninth, every time. So 1 2 3 4 5 6 and 1 2 3 4, leaving me a total of 1 2 3 4 5 6 7 8 9 10. 10 ninths, or 1 and 1/9. Great, so the answer to question 1 is 1 and 1/9. Excellent, let's have a look at question 2. 3/10 add 5/6. Now this question's a little harder because we can't see a direct relationship between our two denominators. 10 is not in the 6 times table and 6 is not in the 10 times table. So we need another method now to help us find an equivalent fraction. So I'm going to teach you a little trick, and if you saw my equivalent fraction video you'll already know this trick, which is great, but if not, then here it is for you. Now what we can do is we could just simply try and find a common multiple, and what I could do is do 10, 20, 30, 40, 50, and say, let's say 60, and then I'd have to do 6, 12, 18, and I'm looking for ones that match. No, none so far. 24, 30, 36, 42, 48, 54, 60. Ah, look what I found. I've found a common multiple, 60. So now I can turn my two fractions into a fraction with 60 as a denominator. So I'm actually finding equivalents for both of these fractions now. But I want you to think about something. We've just had to do this whole process of finding the multiples and writing down all the multiplications of these two numbers, and we ended up with 60. Well, watch this. If I just times my 10 times 6, what do I get? That's right, I get 60. So I didn't need to do this whole multiplication step. I can simply just multiply my two denominators together, and I'm going to get a common multiple because 10 times 6 is always going to be a number that's in both the 10 times table and the 6 times table. So 10 times 6 is 60. So I now have my denominator of 60. And the question I'm now going to ask myself is, how did I get from 10 to 60? What do I need to do to get from 10 to 60? 10 times something equals 60. Well, 10 times 6 equals 60. Therefore, whatever I do to the bottom, I must do to the top, and 3 times 6 is 18. Now I can look at the other side, and I can say, right, how did I get from 6 to 60. 6 times something equals 60. Well, 6 times 10 equals 60. Therefore, 5 also must be multiplied by 10, and it becomes 50 60ths. Now I'm at a point where I can start to answer this. And the question now says 18 60th plus 50 60ths. And I know that I'm working in 60ths, so my answer is going to be 60ths. And 18 plus 58 is 68. But let's have a look at our steps. And again, I can see that I found the common denominator. I renamed the fraction. I added the numerators, but I've not yet simplified if needed. So how can I simplify 68? Well, I can see straight away that we have a common multiple, and an easy common multiple to see is 2. So I can divide by 2, both of these, and 68 divided by 2 leaves me 34, and 60 divided by 2 is 30. But again, I can see that I can actually simplify this even further, because I can still divide this by 2. 34 divided by 2 is 17. And 30 divided by 2 is 15. Now this is quite common when I'm adding up, as we can see already, to end up with an improper fraction, a fraction with a bigger numerator than denominator. That's why in a previous video we've learned how to convert from improper to mixed number. If you haven't done that, go check that out, because we're going to do this quite quickly now. So I've got 17 15ths, and I can divide my 17 by 15 and realize that I've got 1 whole, and then I've got 2 remainder, so it's 15ths. 1 and 2 15ths. Can I simplify that even more? No, because the only common factors are 1. So my answer to this question is 1 and 2 15ths. Okay, let's use our new skills now for question 3, and let's do this super quickly. So I'm not going to bother working out the multiples. All I'm going to do is 8 times 4, and 8 times 4 is 32. So I've got my 2 new denominators, and now I need to just simply work out how I got from 4 to 32. 4 times something equals 32, and I now know that it's going to be 8. So I now need to do 2 times 8, which is 16. 1632 is my equivalent fraction to 2/4. On the other side, how did I get from 8 to 32? Well, I times it by 4, and therefore I now need to times my 3 by 4, and that equals 12. Beautiful, so I now have new fractions that I can add. So I have 12 32s, add 16 32s. So 12 add 16 equals 28. And I was working in 32s, so 28 32s. Can I simplify this fraction even more? Yes, I think I can, because I can divide it by 2. So I could go 14 16ths. Can I go even further? Yes, to 7 eighths. Can I go even further? No, the only common factor would be 1. So my final answer is 7 eighths, a nice clean one. Okay, there we go, 3 questions successfully answered. Let's look back at our things to remember, our steps. First step is to find a common denominator. We're going to use our equivalent fraction skills to do that. Then we're going to rename the fraction. Then we're going to add the numerators, and then we're going to simplify if needed, and if we're in an improper fraction, convert it to a mixed number using our new skills on that as well. So there we go, nice and simple. So I've got 4 questions for you now to work on. Put your answer in the comment section. I'm going to do my best to answer every single one. So press pause on the video now, answer these questions, and I'll get back to you in a minute. Good luck. Okay guys, well done today. Hopefully this video was useful for you. If it was, please think about liking and subscribing the channel, or check out our website www.themathsguide.com for even more content and resources. See you in another video guys. Peace out.